Okay, two things that we are talking about today. We're talking about what's called set builder notation, which is new to you. You haven't seen it before, most of you at least. And then we're talking about absolute value. Jumping right in, set builder notation. It's used to describe a set of numbers. Set builder notation is basically like an inequality. So it's just a different way to express an inequality. If we look at number 1, the way that this is read, x is all numbers. So this is saying all numbers. That line means such that. So this is read all numbers such that the number is bigger than -2. It's just a very formal way of writing an inequality. So the second one then, that x again just represents all numbers. That line means such that. So what this really means, or how this is read, is all numbers such that. Now we're looking at the inequality. What that inequality is telling us is that x is bigger than 0. It's also less than or equal to 3. So all numbers such that the number is greater than 0 and less than or equal to 3. That's very formal. I don't really care that you can write out a sentence. All I care is that you can read the set builder notation. So that's what we're going to practice is the reading part. We're going to take that set builder notation, we're going to graph it, and then we're going to put it in another notation as well. So let's jump right in. Bless you. Okay, practically, here's what I care about. Looking at example A, all you really care about is the inequality. You can ignore the x such at the beginning. So we're going to graph that inequality, and then we're going to put it in what's called interval notation. When we go to graph it, we have -2. If you remember, this inequality is greater than or equal to. So because of that equal sign, we're including the -2. So we put a closed circle here. And then greater than that is everything to the right. So that graph and that inequality express the same information in two different ways. Exactly the same information, just looks different. So then last thing we have is what's called interval notation. Again, it's just a different way of expressing the same set of numbers. With interval notation, you're always going to have two values, and those values tell you where the shading starts and where it ends. So the first one is where we start, second one is where we end. Our shading starts at -2, and then it keeps going. You're going to notice it doesn't end. It heads in the positive direction, so we say it goes to positive infinity. That -2 is included. The way to show included is a bracket. So that bracket just means that it is included. And we'll see in a minute the not included. Now, infinity, it doesn't make sense to say infinity is included because infinity is not a number. Infinity will always get a parenthesis. So I want us to write that. Infinity is always going to be a parenthesis. So that is my expectation. You can take set builder notation and graph it and put it in interval notation. We're going to look at a few more examples so you can see the different ways that this appears. In B, again, all I care about is the inequality. So when we go to graph that, we have 0 and we have 3. 0 is not included, so it gets an open circle. 3 is included, so it gets a closed, and we shade in between. So then our interval notation, again, where the shading starts and where it ends. This one I think is a little bit clearer in terms of the interval notation. The shading starts at 0 and it ends at 3. 0 is not included, so you get a parenthesis. 3 is included, so you get a bracket. And again, when I'm saying included, I'm referring to the inequality. So if there's an equal sign, that value is included, hence the closed circle and the bracket. Questions for me before we do a few more? Okay, C. This is the inequality that we are looking at. If you remember, that inequality is a less than. So that reads x is less than 2. Because 2 is not included, it's an open circle. Less than is everything smaller than it. This is normally the interval notation that people have the hardest time with. Is that 2 going to go in the first spot or the second spot? Second. It's where the shading ends. It's where the shading ends. 2 is not included, so it gets a parenthesis. Okay, there's no starting point for the shading, so we put an infinity. But because those are negative numbers, it's a negative infinity. And again, infinity always gets a parenthesis. So most people forget that negative. Okay. D and E is where things get trickier. What I want you to notice on D and E is this symbol in the middle. So those are two different symbols, and we're going to talk about what they mean. For D, the official term for this symbol is intersection. Intersection is just the word for and. So I'm saying this inequality and this one both have to be true. So we're going to have to graph both. I'm going to graph these in a very specific way, and I'll explain why in a minute. First one I'm going to graph in red. Second one I'm going to graph in green. So x is greater than or equal to -1. -1 is included, and I'm going bigger than that. You'll notice I didn't graph on the number line, and again, I'm going to tell you why in a minute. Then the one in green, x is less than 5. So not included, so it gets an open circle. And it's everything less than that. That is not our answer. That is just work to help us find our answer. Our answer is where both inequalities are true. So here is where both inequalities are true. So that would be here on our number line. And then you just bring down the open and closed circles. So at -1, we're closed. At 5, we're open. So what is in blue is the final answer for the graph. If you just put the green and the red, you're not going to get credit. So our shading then starts at -1 and ends at 5. -1 is included, 5 is not. In E, this is a different symbol. The official term for this symbol is union. What I care about is that you know that it means or. So or tells us this inequality or that one have to be true. They don't have to both be true. So the first one, x is less than or equal to -1. -1 is included, and we're doing everything smaller than that. Second one, x is greater than or equal to 2, so 2 is included, and everything bigger than that. And that is the final answer. You're not looking where they overlap, you're not looking where they're both true. That is the final answer. Any number falling into the shaded region is an answer, or is part of our solution set. Because there are two shadings, we need two different sets of interval notation. So we are going to have interval notation for the first shading, interval notation for the second shading. So for the first one, we start at -infinity and go to -1. Infinity always gets a parenthesis, whereas a -1 gets a bracket because it's included. The second one starts at 2 and goes to positive infinity. Again, 2 is included, infinity is not. You do need a symbol in between the two to tell me what to do with them. So the symbol in between is just the same symbol from over here, the or. You have to have this symbol. I don't want the word or, I don't want a comma, I don't want a plus sign. It has to be that symbol. Questions for me on notation? Two things I want to tell you real quick then. I want to emphasize all three of these express the same information, just different ways. All three have the exact same meaning. In your homework, you might be given a graph and have to put it in interval notation. You might be given the interval notation and have to put it in the graph. You're going to have to be able to go between all three. Please make sure that you read the directions. Last thing I want to tell you before we move on. On the answer key for examples like this, Mrs. Frericks does not use the open and close circles. What she does is she uses brackets instead, brackets and parentheses. So like bracket here, that means a bracket there. I just use open and close. So just use open and close. Sound good? Okay, last thing we have to talk about is absolute value. This is going to be quick, so go to the next page. That absolute value definition I think is confusing, so I'm going to ask you to just ignore it. Here's what I want you to know about absolute value. Absolute value tells us a number's distance from 0. A number's distance from 0. For example, if I take the absolute value of 8, that's saying on a number line, when I look at the number 8, how far is it from 0? Well, it's just 8 units away. If I take the absolute value of -11, that's saying on a number line, when I look at -11, how far away is it from 0? Well, it's 11 units away from 0. What you all tend to remember is that when I plug in a number, it always comes out positive. That's great, because distance is always positive. Okay, let's do 2 examples, and then that will be it for these notes. We are writing the expressions without absolute value symbols. Okay, absolute value acts like parentheses in terms of order of operations. It has to be done first. Absolute value of 8 then is just 8. It's 8 units away from 0. You cannot distribute that negative into the absolute value. That does not work. Because absolute values like parentheses has to be done first. Absolute value of -4 is just +4. It's 4 units away. And then we subtract and we get an answer of +4. Okay, here's what a lot of people want to do in B. They say that pi is negative, so I'm just going to make it positive. 2 plus pi. That is not the correct answer. Not the correct answer. What is the value of pi about?
3.14.
It's about 3.14. This is not how you're going to do the problem. This is just work. What I want you to recognize, 2 minus 3.14 is a negative number. So we are taking the absolute value of a negative number, which is going to make that number positive. You agree? Okay. So 2 minus pi, like we said, is negative. What we can do to make it positive then is we can multiply it by a negative number. If we take a negative number and we multiply it by another negative number, it's going to give us a positive. So I'm going to take that 2 minus pi, which is negative, and multiply it by a negative. So this is a negative, this is also negative. When I multiply them, I'm going to get a positive. So then I distribute, and I get negative 2 add pi. That is my final answer. The way you can check that to see that it makes sense, up here, 2 minus 3.14 is about negative 1.14. When I take the absolute value of that, it's going to be positive 1.14, about. Here, 3.14 plus negative 2 is about 1.14. So you should be able to do that mental check in your head.